In advanced discussions of pivot tables, you will probably hear the term OLAP sooner or later. This is an acronym for Online Analytical Processing and was created as an alternative to OLTP, or Online Transactional Processing. Each of these refers to a type of database, but they are used for different purposes. An OLTP database is used for day-to-day company operations, such as sales to individual customers. Its purpose is to keep track of individual transactions, so that if, for example, a customer complains about a late delivery, information about that transaction can be found and used to solve the problem. In contrast, OLAP databases were developed for a longer run view. They are designed to allow a company to analyze trends rather than to respond to individual transactions. Specifically, they are designed to answer the same sorts of questions answered by pivot tables. For many companies, OLAP databases are the key to their data warehouses for business intelligence. They are typically structured around dimensions and facts in a so-called star schema, similar to what you see here. For example, dimensions for a supermarket chain might include customers, products, stores, and dates. And the facts, also called measures, might contain data such as revenue on line item sales. This structure allows the company to break down the facts by any of the dimensions. In fact, pivot tables are used in such analyses. There are at least two differences between OLAP databases and Excel datasets for creating pivot tables. First, OLAP datasets are pre-processed for very quick analysis. The results are stored in an OLAP cube file. You can think of this like a Rubik's Cube, where each face of the cube corresponds to a dimension, and each individual subcube of the overall cube contains aggregate results for a combination of categories, such as total revenue for product 3 at store 7 on August 3rd. Because the aggregates have been pre-processed, you get extremely fast results when you build a typical pivot table, even though the size of the underlying database is typically huge. The other difference is the presence of hierarchies in dimensions. These hierarchies let you drill down in the pivot table. For example, the date dimension has a natural hierarchy, from year to quarter to month to day. So you could start by looking at yearly totals and eventually drill down to daily totals. As another example, the product dimension typically has a natural hierarchy, such as from product department to product category to product subcategory to individual product. Or as a third example, the store dimension might have the hierarchy continent to country to region to city. In earlier versions of Excel, you could create your own OLAP cubes. However, Microsoft discontinued this functionality in Excel 2007 and provided it instead in Analysis Services as part of its SQL Server package. Therefore, if you want to create OLAP cubes, at least with Microsoft software, you have to use SQL Server Analysis Services, abbreviated SSAS. Among other things, this software allows you to create offline cubes, which you can then view in Excel with pivot tables. It's not likely that you will be doing this, but I will briefly show what it looks like. I have an offline cube called foodmart.cub with supermarket data. This is not an Excel file, and I can't open it directly in Excel. However, I can create a pivot table from it by using the external data option and browsing for the cube file. This opens a blank pivot table as usual, but the pivot table fields list looks somewhat different. The facts are in one group, and the dimensions are in groups below the facts. Now there are certain restrictions. Only facts can go in the values area, and only dimensions can go in the other areas. In addition, facts must be summarized by sums. This is because of the pre-processing of the data in the cube file. To show how drilling down works, I will first place revenue in the values area. Then I will drag date YQMD, a hierarchy, to the rows area and then drill down. Alternatively, I will do the same with a product full hierarchy. From family to department to category to subcategory to brand to product. Obviously, this ability to drill down lets a manager see the big picture or the fine details very quickly. Note that when a pivot table is based on an OLAP source, the OLAP Tools drop-down on the Pivot Table Tools Analyze ribbon is enabled. Otherwise, this drop-down is disabled. OLAP is actually a huge topic, and Microsoft is only one of many software vendors with OLAP capabilities. However, with the advent of Microsoft's Power Pivot add-in, introduced with Excel 2010 and discussed in detail in other companion videos, you can get much of the functionality of OLAP without requiring SQL Server analysis services or other specialized software. Actually, Power Pivot was built from the SQL Server Analysis Services OLAP technology, so under the hood they have much in common.